Good morning, this is Dr. Turner for Fundamental Math. Today we're going to be looking at 8.1. 8.1 is getting into a little bit of just basic probability and statistics. Starting with 8.1, we are looking at sample spaces. So our objective here is pretty simple for 8.1. We want to look at what a sample space is and then determine how many outcomes are possible based on a sample space. So when you take something, let's say like a die, and you roll it, there are a certain number of outcomes. Now, a lot of us are familiar with a common gaming die, and typically, unless it's for something specific, you roll the die and you get an outcome of 1 through 6. So if I were to list out those possibilities, 1 through 6, 1, 2, 3, 4, 5, and 6, those are all the possible outcomes. By doing that, by writing them out, illustrating or written, we are creating what's known as a sample space. Now, for a single die, as we mentioned, we have 1 through 6, and I could draw that out if I wanted to, albeit crudely, or I could just simply list out the possibilities, 1, 2, 3, 4, 5, and 6. This is what a sample space is. It's writing out all the possible outcomes of a probability event. It's a way to visualize it. It's also going to help us answer some basic probability questions as we get into 6.2 and 6.3. So unless the directions are telling you to do something specifically, you're welcome to treat your sample space however you'd like, whatever makes more sense to you. Obviously, rolling a die is a very common probability question. Also, when you're flipping a coin that has either heads or tails on depending on which side you flip it on. Now, for a coin, that's pretty simple, right? If I flip one coin, I could have heads or tails. But if I were to flip, let's say 3 coins or 4 coins or 5 coins, well, then that becomes a little bit trickier because that's a lot to keep track of. And so sometimes, rather than just trying to list out all the possible combinations off the top of my head, in creating the sample space, we can do what's known as a sample tree. So for instance, in the example of flipping a coin 3 times, my first coin could be heads or tails. And I would call that my first toss. Okay. And then the second time I flip the coin, it could again be heads or tails. And then the third time I tossed, or if the time I tossed the third coin, it could again be heads or tails. So by writing all of this out, I can sort of count how many possibilities there are in determining different probability questions. So if you need to, you can draw it out. HHH would give me 3 heads. HHT would give me 2 heads and then a tails. HTH would be a heads, then a tails, then a heads, etc. And you could fill this out. You don't have to do the tree, but sometimes it helps, especially if you are doing, let's say, 5 coin tosses or 10 coin tosses. It might help to write out the tree just so you're not leaving out any of the possible outcomes. But by doing that, I can see I have 2 possibilities here, 2 possibilities here, 2 possibilities here, 2 times 2 times 2 gives me a total of 8 possible outcomes in my sample space. Again, that's listing out the coin being flipped 3 times or 3 different coins and what combinations there are of those 3 being heads or tails. Now, when we roll 2 dice, this is another thing that comes up quite commonly. When we have 2 dice, because there are 6 sides on each die, 6 times 6, that gives me a total of 36 outcomes. Now, again, if you want to, you could illustrate this, showing the faces of the die. And sometimes in a sample space table, you'll see that. But otherwise, you can draw sort of like a multiplication table. And you can draw this out and say, okay, if I roll a die, I roll the first die, doesn't matter which one is which, but when I roll the first die, I can have 1, 2, 3, 4, 5, or 6. And if I roll the second die, I could have 1, 2, 3, 4, 5, 6. And so looking at those possible outcomes, I could have 2 1s, I could have 1, then a 2, I could have 1, then a 3, etc., etc. So you could fill this out, writing out all the possible outcomes, and it would go the same way here, 2, 1, 3, 1, 4, 1, etc. Fill all this out, but by the time you're done filling out this table, you will have a 6 by 6 or 36 different combinations that you can get by rolling 2 dice, assuming we're distinguishing between the first die and the second die. If we're not distinguishing between those 2 die, then it changes the probability a little bit, but for now, this is what we're looking at. And then the other probability we want to familiarize ourselves with that's very common to come up is a deck of cards. Now, in a standard deck of playing cards, you have 4 suits. You have spades, something like this. You have clubs. And both of those are black in color. And then you have 2 red colors. One is hearts and one is diamonds. Those are called suits, or typically they're called suits. And then you also have face values. So based on these, you have 2 through 10. So 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have the jacks, the queens, the kings, and the aces. There are a total of 13 face values, ace through 10, and then jack, queen, king. And there are 4 suits, spades, clubs, hearts, and diamonds. 4 possible suits, 13 possible face values. That gives you a total of 52 cards in a deck, which also creates 52 items in your sample space. So for 8.1, all you're asked to do is simply identify how many outcomes are possible. And then also by looking at a sample space, like one of these diagrams, being able to say, well, what probability is being shown? That's it for today. If you guys have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.